Hello students, welcome to Diksha Karnataka YouTube channel. As you all know, mock test 3 has been released, right? I hope you guys have done well. So in this video, I'm going to discuss the solution of mock test 3, COMEDK 2024 and physics part 2, question number 31 to 60. If you haven't downloaded the question paper, please join the WhatsApp channel which is given in the description box. Okay, in there you will get the detailed solution and the question paper. Yeah, so let's start. Question number 1. The relative permeability of a medium is, what is its magnetic susceptibility? Okay, relative permeability of the medium is 0.075. What is its magnetic susceptibility? We know that relative permeability of the medium mu r is equal to 1 plus here 1 plus magnetic susceptibility, right? So magnetic susceptibility is equal to mu r minus 1. So now magnetic susceptibility is equal to mu r minus 1, that is 0.075 minus 1. So now solve this, you will get minus 0.925. The correct option is B. Okay, the correct option is B. Okay, next question, question number 2. If a galvanometer current is 10 milliampere, resistance of the galvanometer is 40 ohm and shunt of 2 ohm is connected to the galvanometer, the maximum current which can be measured by this ammeter is. Okay, so here this is the galvanometer and this is the shunt resistance. Okay, so we need to connect shunt resistance parallelly to the galvanometer so that we can convert galvanometer to ammeter. Here the total current is I, current flowing through the galvanometer is Ig, and current flowing through the shunt resistance is I minus Ig. Okay, so here we need to find the maximum current which can be measured by this ammeter, right? That is the value of I, right? We need to find the value of I. So here Ig into G, that is potential difference across the G, is equal to I minus Ig into S, right? I minus Ig into S. So Ig into G plus Ig into S is equal to I into S, right? So we need to find the value of I equal to Ig into G plus S divided by S. So now solve this. Okay, Ig is equal to how much? 10 milliampere, right? So 10 milliampere and G plus S is 42 divided by S is 2. So 2 2s are 2 1s are 2, right? 2 2s are 4. So 21 into 2 is 42. Yeah. So then I is equal to, here 21 into 10 is 210. 210 into 10 to the power minus 3, right? 210 into 10 to the power minus 3 is 0.21 ampere. So the correct option is A. Okay, correct option is A. Question number 3. A magnet of length 0.1 meter and pole of strength 10 to the power minus 4 ampere meter is kept in a magnetic field of 30 Weber per meter square at an angle of 30 degree. The couple acting on it is dash into 10 to the power minus 4 Newton meter. Okay, the pole strength of the magnet is given, the length of the magnet is given, right? So the couple acting on the magnet, okay, couple acting on the magnet is equal to magnetic moment into B into sine theta, right? Theta is angle between magnetic moment and B. What is the angle between magnetic moment and B? It is 30 degree, right? So now tau equal to, what is the magnetic moment? Magnetic moment is equal to here magnetic moment is equal to pole strength small m into the length of the magnet, right? Length of the magnet into B sine theta. We need to find tau. So tau equal to m is here 10 to the power minus 4 into L is 10 to the power minus 1 meter, okay, into B is 30 Weber per meter square, into sine theta, that is 1 by 2, sine 30 degrees 1 by 2. So now solve this, you will get tau equal to 1.5 into 10 to the power minus 4 Newton meter. So here we need to fill the blank, right? So the value here, the value will be 1.5. The correct option is B. Question number 4. To produce a magnetic field of pi Tesla at the center of circular loop of diameter 1 meter, the current flowing through the loop is, okay, we need to find the current flowing through the loop, right? The magnetic field produced by the circular loop is pi Tesla, right? So magnetic field due to the circular loop at its center, right, at its center will be mu naught I divided by 2r, okay, mu naught I divided by 2r. So now what we need to find? Here we need to find current flowing through the loop, right? So I equal to B into 2r divided by mu naught. So now I equal to here B is pi Tesla into 2 into diameter is 1 meter, that is 0.5 meter, divided by diameter is 1 meter, right? So radius is 0.5 meter, 0.5 into here 2, right, that is 1 only, yeah, divided by mu naught is 4 pi into 10 to the power minus 7. So pi will get cancelled, okay. So then here 1 by 0.5 is 1 by 2, okay, so this will be 1 by 8, right? So 2 by, okay, so 2 into 0.5 is 1, right, isn't it? So this is 1 by 4, then 1 by 4 into 10 to the power minus 7, 1 by 4 is 0.25, so I equal to 0.25 into 10 to the power plus 7 ampere. So I equal to 2.5 into 10 to the power 6 ampere. The correct option is C. Question number 5. Two wires of same length are shaped into square and a circle. If they carry same current, the ratio of the magnetic moment is. We know that magnetic moment M equal to I into A. A is the area, right? I is the current in the loop, isn't it? Yeah, current in the given loop, okay. So let us find area of the square loop and area of the circle. Now the length of the wire is L. Let's say length of the wire is L, okay. Now this wire is shaped into circle, right? So the length of the wire L is equal to 2 pi r, right? Length of the wire L is equal to 2 pi r, and area of the circle AC is equal to pi into r square. Now the same wire is shaped into square, right? So the side of the squares is L by 4, L by 4, L by 4, right? So therefore here side of the square, right, Ls equal to L by 4. So area of the square will be L square by 16, right? L square by 16. So L equal to 2 pi r, right? So area of the, let's write area of the square in terms of pi. So now area of the square is equal to, here L square is 4 pi square r square, 4 pi square r square divided by 16. So AS is equal to here pi square r square divided by 16. So this is the area of the square loop in terms of pi, right? So now we need to find the ratio of the magnetic moment of the square loop to the magnetic moment of the circle is equal to MS equal to, here anyway current will get cancelled, current in the square loop and current in the circular coil will get cancelled. So then, so this is 4, okay, not 16, it is 4. Now pi square r square divided by 16 whole divided by 4, again, sorry, divided by 4. 4 whole divided by pi square, sorry, pi into r square. So r square will get cancelled. Here pi will get cancelled. Now the ratio will be pi is to 4. The correct option is C. Question number 6. Two long conductors separated by a distance d carry current I1 and I2 in the same direction. Okay, so they both carry a current in the same direction, right? I1 and I2. They exert a force F on each other. So the force acting on I2 due to I1, okay, force acting on second wire due to first wire or first wire due to second wire is F. So F equal to mu naught into I1 into I2 into L divided by 4 pi, sorry, not 4 pi, it is 2 pi, 2 pi d, okay, 2 pi d. Now the current in one of them is increased to 2 times and its direction is reversed. Okay, current in one of them is increased to 2 times. Let's say here I2 is increased to 2 times. Okay, so this is 2I2, 2I2. I2 dash is equal to 2I2. Okay, and the distance is increased to 3. And the current direction is reversed, I1 and I2, 2I2, okay, current direction is reversed. Here the current directions are same, therefore the both wire will repel each other, okay, sorry, both wire will attract each other, okay. Here the current directions are opposite, so both wire will repel each other, okay. In first case both wire will attract each other, in second case both wire will repel each other. So now here the distance is also increased to 3d. The new value of the force between them is, okay, we need to find F dash. F dash is equal to mu naught I1 into 2I2 into L divided by 2 pi into 3d, right? So now F dash is equal to here mu naught into I1 into I2 into L divided by 2 pi d into 2 by 3. So now mu naught I1 I2 into L divided by 2 pi d is F. So F dash is equal to 2 by 3 times F. The correct option is C. Question number 7. Two long thin wires ABC and DEF are arranged as shown in the figure. They carry currents I. The magnitude of the magnetic field at O is, okay, we need to find magnitude of the magnetic field at O, right? Okay, so this is the wire, right? One wire and the other wire, right? Due to AB part, magnetic field at O is 0. Apply right hand thumb rule. Due to AB part, magnetic field at O is 0. Similarly, due to DE part, magnetic field at O is 0. Right? So now let us find magnetic field due to BC part and EF part. So this is semi-infinite wire, right? So magnetic field at O, right? Magnetic field at O is equal to magnetic field due to BC part plus magnetic field due to EF part. Now magnetic field at O is equal to magnetic field due to BC part. So this is semi-infinite wire. So therefore this will be mu naught I divided by, so apply right hand thumb rule, okay, the magnetic field is outward from the plane due to the BC part, okay. So mu naught I divided by 4 pi A, the distance is A, right, 4 pi A. So what is the direction of the magnetic field? Outward from the plane, right, outward from the plane, plus magnetic field due to EF part. Here magnetic field is due to EF part is also outward from the plane. So this will be mu naught I divided by 4 pi A, outward from the plane. So now solve this, you will get mu naught I divided by 2 pi a. The direction is outward from the plane. So the correct option is C. Question number 8. The moment of magnet 15 centimeter cross 2 centimeter cross 1 centimeter. This is the volume, okay, volume of the magnet is 1.2 ampere per meter square. That is magnetic moment M equal to 1.2 ampere per meter square. What is the intensity of the magnetization? Intensity of the magnetization is magnetic moment per unit volume or magnetic moment divided by volume. So I equal to here M, right? So M is 1.2 ampere per meter square and the volume is here 15 into 2 30, okay, so 30 centimeter cube, that is 30 into 10 to the power minus 6. So now I is equal to here solve this, okay, solve this, you will get 4 into 10 to the power 4 ampere per meter. The correct option is A. Okay. Question number 9. Nucleus of an atom whose atomic mass is 24 consists of. Option A says 11 electron. Okay, so nucleus doesn't have any electron, right? So option A is wrong. Option B is also wrong. Option C 11 protons and 13 neutrons, correct. 11 protons and 13 electrons. Option D is wrong. Nucleus cannot have electrons, okay, nucleus cannot have electrons, so option C is the correct answer. Question number 10. A tritium contains, a tritium contains, right? So how you write tritium? 3H1, right? So 3 represents mass number, 1 represents atomic number. So A is 3, Z equal to 1, right? So A is mass number, that is number of neutrons. So A equal to number of, okay, so this is nucleon, right? Nucleon, that is number of neutron plus proton, right? Number of neutron plus number of proton is equal to 3, right? So what is the number of neutron? Number of neutron is equal to 3 minus 1, that is 2. So 2 neutron and 1 proton. Here atomic number is number of proton, okay. So 2 neutron, 1 proton. So the correct option is A. Question number 11. According to classical theory, the circular path of an electron in Rutherford atomic model is. So according to classical theory, the circular path of the electron is spiral, right? In Rutherford atomic model. Why? Here this is the nucleus, right? Circular path of the electron is spiral, right? So why it is spiral, right? Why it is spiral? Because when electron moves in circular path, electron will have acceleration, isn't it? Electron moves with acceleration, right? Isn't it? If charged particle moves with some acceleration, it radiates energy, right? The charged particle radiates energy, that is EM wave will emit, right? Charged particle radiates energy, right? So when charged particle radiates energy, so that particle loses its energy, right? That particle loses its energy. So therefore, the radius of this radius will be decreases, right? The radius of the circular path will be decreases. Eventually, the electron will fall on the nucleus, right? So option A is the correct answer. Okay, circular path of an electron in a Rutherford atom model is spiral. Question number 12. As one considers orbit with higher values of n in hydrogen atom, the electric potential energy of the atom. Okay, so electric potential energy of the atom, electric potential energy of the atom, U is equal to, right? U is equal to total energy divided by 2, right? Total energy divided by 2. Sorry, minus total energy divided by 2. So now electric potential energy of the system, U is equal to minus total energy is here 13.6 divided by n square into z square, for hydrogen like atom. In hydrogen atom, Z equal to 1. Okay, Z equal to 1 for hydrogen atom. Okay, so 13.6 into Z square divided by N square. Okay, so this is total energy divided by 2. Okay, not minus. Yeah. So now this will be minus 13.6 into Z square divided by 2. N square, right? So as the value of N increases, what happens? The magnitude of this will be decreases, right? Magnitude of this will be decreases, but the negative sign is there, right? So the potential energy will be increases. The correct option is B. Okay, potential energy will be increases. Question number 13. Which of the following statements is true for hydrogen atom? Angular momentum is directly proportional to 1 by n. Wrong, right? Angular momentum m into v into r is equal to nh by 2 pi. So angular momentum L is directly proportional to n. So option A is wrong. Let's check option B. Linear momentum equal to 1 by n, right? Okay. Here, radius of the nth orbit is directly proportional to square of the principal quantum number, right? So r equal to n square, right? So mv is equal to nh divided by 2 pi into n square. So n will get cancelled. mv is linear momentum. So linear momentum is directly proportional to 1 by n. Correct. Okay. And the radius is directly proportional to 1 by n. Wrong. Radius is directly proportional to n square, right? Option C is wrong. Option D, energy is directly proportional to 1 by n. Again, it is wrong. Why? Because energy is equal to minus energy of the electron in nth orbit is equal to minus 13.6 divided by n square. Okay. Into Z square. Z is 1 for hydrogen atom. So E is directly proportional to 1 by n square. Okay. Not 1 by n. So option D is also wrong. So the correct option is B. Question number 14. Doubly ionized helium atom and hydrogen ions are accelerated from rest through the same potential difference. Okay, doubly ionized helium atom, okay, and hydrogen ion, that is proton and alpha particle, right? Accelerated through the same potential difference. The ratio of the final velocities of the helium and hydrogen is, okay, we need to find the ratio of the final velocity of the helium and hydrogen, right? Okay, when the charged particle accelerated through the potential difference, what happens? Its kinetic energy increases and electrical potential energy decreases, right? So the loss in gain in kinetic energy is equal to loss in potential energy, right? We need to find the final velocity of the helium and hydrogen. So what is kinetic energy? Kinetic energy is half mv square equal to q into half mv square equal to q into potential difference v. So now v, that is velocity, is equal to root of 2qv divided by m. Okay, 2qv divided by m. These three atoms accelerated through the same potential difference. So v is same. Okay, so v, that is velocity, is directly proportional to q by m. Okay, so now we need to find the ratio of the final velocity of the helium, that is alpha particle, to the hydrogen, that is proton, is equal to root of q alpha by m alpha whole divided by root of qp by mp. Okay, so now v alpha divided by vp is equal to root of q alpha divided by qp into root of mp divided by m alpha. So now v alpha divided by vp is equal to q alpha is 2 times qp. Qp is charge of the hydrogen atom, that is charge of the hydrogen atom. Okay, q alpha is a charge of the alpha particle or helium, so which is equal to 2 times charge of the hydrogen atom, right? So 2 times qp divided by qp into root of mp is mass of the hydrogen atom divided by m alpha is mass of the helium atom. Okay, mass of the helium atom is 4 times mass of the hydrogen atom. So MP will get cancelled, QP will get cancelled. So root of 2 by root of 4, so that is 1 by root 2. Okay, 1 by root 2. So the ratio will be 1 is to root 2. The correct option is A. Question number 15. What is the conductivity of a semiconductor in per ohm per meter? Okay, conductivity of the semiconductor, that is sigma, if electron density, that is Ne, and hole density, that is NH. Okay, electron density and hole density is given. Mu E, that is mobility of the electron, and mobility of the hole is also given, right? So we know that the conductivity of the semiconductor sigma is equal to E into Ne into mu E plus NH into mu H, right? So what is E? Charge of the electron, right? So sigma equal to 1.6 into 1.6 into 10 to the power minus 10, sorry, minus 19 into Ne. Ne is 5 into 10 to the power 12 into mu E is 2.3 plus NH is 8 into 10 to the power 13 into 0.01, right? 0.01. So now solve this. Okay, solve this. You will get 1.968. 1.968. The correct option is B. Okay, 1.968. So this is 13. Okay, not minus 3. 13. Yeah. Next question. Question number 16. If c is the velocity of light, which of the following is correct? Okay, we have to find the correct option, right? Here in the option they have given speed of light in terms of absolute permeability and absolute permittivity, right? So we know that speed of light from the Maxwell's equation, right? Speed of light c equal to 1 divided by root of mu naught into epsilon naught, right? So now mu naught into epsilon naught is equal to 1 divided by c square. The correct option is D. Question number 17. Temperature coefficient of resistance of semiconductor is, so it is negative, right? Why it is negative? Because as you increase the temperature, the resistance of the semiconductor decreases, right? So that's why this temperature coefficient of the resistance of the semiconductor is negative. Question number 18. A potential barrier of 0.3 volt exists across PN junction if the depletion region is 1 micrometer wide. What is the intensity of the electric field in this region? So intensity of the electric field E is equal to barrier potential V divided by D, that is depletion region, the length of the depletion region. So E is equal to V is 0.3 divided by D, that is 10 to the power minus 6. So E equal to 3 into 10 to the power 5 volt per meter. So the correct option is B. Question number 19. In the half wave rectifier circuit operating from 50 hertz main frequency, the fundamental frequency in the ripple would be, okay, so the fundamental frequency in the ripple would be 50 hertz only, right? So why? Because it is half wave rectifier, right? So we get the output only 1/2 cycle of the input, right, in the half wave rectifier. So therefore ripple of output will be 50 hertz. That is same. Option B is the correct answer. Question number 20. Ozone layer, Earth's atmosphere will not. Ozone layer, Earth's atmosphere will not. Okay. Option A says prevent infrared radiation from sun reaching Earth. So this is wrong, right? Why? Ozone layer, Earth's atmosphere will prevent infrared radiation from sun reaching Earth, right? Isn't it? So it will prevent infrared radiation and ultraviolet radiation, okay, from sun reaching the Earth, isn't it? Prevent infrared radiation originating from Earth. Okay, this one is wrong. Option C, prevent ultraviolet rays from sun. Correct. Oh, sorry, this one is also wrong, right? Yeah. D, reflect back radio waves. Yeah, this is, it will not reflect back radio waves. Yeah, this is correct, right? It will not reflect back radio waves. Okay. Question number 21. A circular coil of radius 0.1 meter has 80 turns of wire. If the magnetic field through the coil increases from 0 to 2 Tesla, that is delta B is equal to 2 Tesla. Okay, in 0.4 second, that is delta T is equal to 0.4 second, and the coil is connected to a 11 ohm resistor, R equal to 11 ohm. What is the current flow through the resistor during the 0.4 second? That is, we need to find induced current, right? Induced current I equal to induced EMF divided by R. So induced EMF is N into delta phi divided by delta T whole divided by R. That is induced current. So now I equal to N is 80 turns, right? Okay, N into delta phi is, here the area of the circular coil is not changing, right? But the magnetic field is changing. So area A into delta B, delta phi is change in magnetic flux equal to A into delta B divided by delta T whole divided by R. So now I equal to, here N, right? N is 80 turns into area A is pi into R square, right? Pi is 22 by 7 into R square is 0.1 squared, 0.1 squared is 10 to the power minus 2 into delta B is 2 whole divided by R is here, what is the resistance? 11. So 11 2s are 22, okay. Then I equal to, here solve this, okay, solve this, you will get 8, correct, right? N is 80, pi R square, R is 0.1, so 0.1 squared is 10 to the power minus 4, okay, 0.1 squared is, 0.1 is 10 to the power minus 1, sorry, 10 to the power minus 2 only, into 2, right? Okay, divided by 0.4 is also there, right? There is 4 into 10 to the power minus 2, minus 1. Okay, here 4 will also get cancelled. So the current through the resistor will be 8 by 7 ampere. The correct option is A. Question number 22. In series LCR circuit, the voltage across the resistance, capacitance and inductance is 10 volt each. If the capacitance is short circuited, the voltage across the inductance will be, okay, we need to find the voltage across the inductance, that is VL. So VL equal to I into XL, right? Voltage across the resistance, capacitance and inductance is same, that is 10 volts. So therefore, the impedance will also be same, right? That is R equal to XC equal to XL, right? Now capacitor is short circuited, so R equal to XL, right? So now the current in the circuit, I is equal to V divided by root of R square plus XL square, XL equal to R. So V equal to I equal to V is 10 volt divided by root 2 times R, okay, root 2 times R, right? So this is the current in the circuit. So voltage across the inductor is equal to I into XL, right? XL is R. So VL is equal to I is 10 divided by root 2 into R into R. R will get cancelled. VL equal to 10 divided by root 2 volt. The correct option is C. Question number 23. If N is the number of turns in a coil, the value of self-inductance varies as. Okay, we need to find the value of self-inductance, right? Okay, we need to find the self-inductance which is directly proportional to N to the power X. We need to find X, right? I mean, what is the power? Yeah. So we know that self-inductance L into I, relationship between self-inductance, current and magnetic flux. L into I equal to N into phi. N into phi, right? So now L equal to N, sorry, phi is A into B, okay? Phi is A into B into N divided by I. So now L equal to N into area of the coil, right? So that will be pi into R square, into B. B is magnetic field due to the coil, right? Magnetic field due to the coil or the solenoid. Okay, here they have given coil, right? Isn't it? So N into mu naught I divided by 2R, right? Divided by 2R into I. So now I will get cancelled. Okay, here R will get cancelled. So L is directly proportional to N square. L is directly proportional to N squared. So the correct option is C. Question number 24. In an AC circuit, the reactance is equal to the resistance. The power factor of the circuit will be. Okay, reactance is equal to the resistance, right? We need to find the power factor. We know that tan phi is equal to XL minus XC divided by R. XL minus XC is X. So tan phi is equal to X divided by R. X equal to R. So tan phi equal to 1. So phi equal to 45 degree, right? So we need to find the power factor. So power factor cos phi is equal to cos 45 degree. So which is equal to 1 by root 2. The correct option is C. Question number 25. The core of a transformer is laminated to reduce eddy current, right? The direct question. Option D is the correct answer. Question number 26. The image found by an objective of compound microscope is real and enlarged. Option C is the correct answer. Okay. 27. Question number 27. A substance is behaving as convex lens in air, concave lens in water, then its refractive index. Okay. So here the convex lens behaving, okay, a substance behaving as convex lens in air, right? So that is, it is behaving as converging lens, isn't it? Convex lens is converging lens. So therefore, the refractive index of the substance with respect to air, right? Refractive index of the substance, okay? Refractive index of the substance must be greater than refractive index of the air. Okay, refractive index of the substance must be greater than refractive index of the air. Then only the substance behaves. Then only substance can behave like a convex lens. Okay, apply this formula, the lens maker's formula. You will get the answer. Okay, mu minus 1 into 1 by R1 minus 1 by R2. Sorry. Okay, so then that substance is immersed in water, right? Now it behaves like a concave lens, right? That is, it is a diverging lens. Okay, for diverging lens, refractive index of the substance must be lesser than refractive index of the water. Okay, refractive index of the substance must be lesser than refractive index of the water. Okay, then only the substance can behave like a concave lens. Okay, so the refractive index is greater than air, correct, but less than water, correct. So option A is the correct answer. Okay. Question number 28. The locus of all particles in a medium vibrating in the same phase is called wavefront, right? The correct option is C. That is the definition of the wavefront, right? Question number 29. In a Young's double slit experiment, D equal to 0.5 millimeter. That is, the slit width is 0.5 millimeter and capital D equal to 100 centimeter, that is 1 meter. Capital D is distance between the slits and the screen. It is found that ninth bright fringe, okay, bright fringe, when we will get bright fringe, here y equal to n lambda divided by d. So this is the condition for bright fringe, right? Or constructive interference, right? At a distance of 7.5 millimeter from the second dark fringe pattern. That is, here this is bright constructive interference. Okay, now the destructive interference is equal to 2n minus 1 into lambda d divided by 2d. Okay, the wavelength of the light used is, okay, we need to find the value of lambda. Okay, so yb of ninth minus yb of second is equal to 0.75 millimeter, that is 0.75 into 10 to the power minus 3, right? So what is yb of ninth? 9 lambda d, okay, I will take lambda as common, so lambda is common, 9d divided by 2d. Okay, take lambda d by d as common, okay, lambda d by d as common, lambda into capital D by small d as common, so lambda d divided by d as common. So now n is 9, okay, so 9 minus 2n minus 1, that is here n is 2, 2 into 2 is 4, 4 minus 1 is 3, so 3 by 2, 3 by 2, okay, which is equal to 0.75, 0.75 is 3 by 4, right, 3 by 4, 3 by 4 into 10 to the power minus 3. The value of capital D and small d is given, right? So lambda is equal to, here this is 18, 18 minus 3 is 15, okay, so 15 by 2, right? So lambda is equal to 3 by 4 into 2d divided by 15 into d into 10 to the power minus 3. So now lambda is equal to 3 by 4, right? Here 4, 3 5s are 15, okay, this is 2. So then here 1 by 10, right? So 1 by 10 into small d is 0.5 millimeter, that is 5 into 10 to the power minus 4 divided by capital D is 1 meter into 10 to the power minus 3. So this is 2, right? So now solve this, you will get lambda equal to 5000 angstrom. The correct option is C. Question number 30 and the last one. The focal length of the biconvex lens of refractive index is 1.5 is 0.06 meter. Let's write the lens maker's formula, that is 1 divided by f equal to mu minus 1 into 1 by r1 minus 1 by r2. So r1 equal to plus r1, okay, and r2 is equal to minus r2, right? r2 is negative r2. So now 1 by f is equal to mu minus 1 into 1 by r1 plus 1 by r2, 1 by r1 plus 1 by r2, okay. The radii of curvature in the ratio 1:2, that is r1 divided by r2 is equal to 1 by 2, okay. So now r2 is equal to 2 times r1, right? r2 is equal to 2 times r1. Then the radii of curvature of the lens surfaces are easy, right? So now substitute the r2 value here, right? So focal length is also given 0.06 meter, that is 6 centimeter. So 1 by 6 is equal to mu is 1.5. So 1.5 minus 1 is 0.5. 0.5 into, so 1 by r1 plus 1 by 2r1. So 1 by 6 equal to 0.5 into, this will be 3 divided by 2r1, okay, 3 by 2 r1. So now 2 3s are 6, right? 2 3s are 6. So now r1 is equal to 0.5, 0.5 into 3 into 3, 9. So r1 equal to, solve this, you will get 0.045 meter, okay. So if r1 equal to 0.045 meter, then r2 is equal to 0.09 meter. So the correct option is A. That's it, okay. Thank you so much for watching this video, okay. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.